Okay, good morning, everyone. How can something this size tell us about the origins of the universe on a galactic scale? So how big am I really talking about when I say the galactic scale? So if you imagine this here is the size of our sun, which is in our solar system, well then the nearest star to us, which is called Alpha Centauri, is actually about 350 miles away. So that would be the distance from Zurich to Paris approximately. Okay, that mightn't seem so big, but then if we try and imagine the size of our galaxy as a whole, that would take us on a trip to the moon about 30 times. So these scales are absolutely huge. But how did it get so big in the first place? Well, it all started with a big bang. The universe began as a very, very hot, dense ball of gas and suddenly expanded. And as it expanded, it cooled very, very slowly, and it's still expanding and cooling today. But as it changed from being very, very hot to being very, very cool, a lot of other things changed as well. And scientists call these things phase transitions. And this is what I study. I study how things change as they're heated or as they're cooled. Well, phase transitions are actually something that we see in everyday life. The most obvious example, I think, is when we take water from our tap and turn it into ice cubes. There's a phase transition there when we cool it. So water, which we can normally not hold without having a glass, because the molecules of water are free to slip around each other, and that's why we need a cup or something to hold water in a container. However, when we cool water below 0 degrees, what happens is all these molecules are fixed and locked into a particular structure, just like building blocks in cement. And then we can actually pick up a block of ice. So in cooling water from above 0 degrees centigrade to below it, we actually have a phase transition. I still haven't told you exactly how this can tell us about the origins of the universe. Well, a very particular type of phase transition occurs both in the early universe and in some materials that I study. This particular type of phase transition is best understood if you imagine having a dinner party where you have a table of 10 people, say, in a circular table, and you cunningly put a glass of water exactly in between each of the guests. And we don't have any social convention which tells them which side they should actually drink from. Well, if you at the same time tell everyone to drink, you'll end up with a problem. Some people will go for the glass on their left-hand side, some will go for the glass on their right-hand side. At the end of this, you'll end up, we'll say, with two defective people. Someone will have no glass at all, and someone will have two. Well, these types of defects occur in the transitions in the early universe and also in some condensed matter systems. And the exact same physics describes these phase transitions. So, for a physicist, really, size doesn't matter.